Hello, students. That was a heck of a lot of stuff going through all of those derivative proofs. Uh, but what's the point of all of that? That's mentally some of the hardest stuff that we're going to do this year, if not the hardest stuff that we're going to do this year. It's exhausting to try to understand things that you're being guided through, but you don't really have a clear understanding of what's going on there. So here we're going to put these things all together. And here's our list of derivative shortcuts so far. We've got the derivative of a constant is going to be 0. We've got the derivative of a constant multiplied by a function is that constant times the derivative of the function. So we can always kind of ignore the constant out front when we're taking derivatives. We've got the derivative of a power function, so some kind of variable raised to a numerical exponent. That's going to be that whatever that exponent is times that variable to 1 power less. That's the power rule. We've got the product rule. The derivative of two functions multiplied together is going to be the derivative of the first times the second plus the derivative of the second times the first. And the product rule's younger sibling, the quotient rule, the derivative of two functions being divided is the derivative of the top times the bottom function minus the derivative of the bottom times the top, all over the bottom squared. These are the derivatives that we've learned so far, and what we're going to do is try some of these things out. I missed one in writing these down. We also have a rule that's a shortcut for two functions being added together. You could also say subtracted, since those are inverse operations. And that ends up being f prime of x plus or minus g prime of x. All right, this is our first bigger derivative. We've got a nice polynomial here. And the first thing I notice is we got pieces that are being added together. And because they're being added together, I'm going to use that derivative of two things being added together rule, otherwise known as a sum. I don't know why I used that long phrase to describe that. But we're also going to use some power rules for each part of this. So our power rule for x to the third, we'll call this f prime of x, is going to be 3x squared. Then I'm going to use my sum and difference rule. And here we've got a constant times x squared. So we can treat that as 6 times the derivative of x squared. That's a power rule. X to the second is going to be 2 times x to the first. We've got another sum and difference part till we get to 9x. The derivative of 9x is going to be 9. Which we know for two reasons. The first is that this is really x to the first. I can bring that 1 down. This would be x to the 0. Anything to the 0 power is just 1. I should say anything except 0, but we're going to ignore that for now. And then we've got that 9 multiplier out in front. The other way to realize this is that derivatives are slopes. I'm going to say that again. Derivatives are slopes. The slope of 9x is 9. And then finally, we have a constant at the end. The derivative of a constant is 0. My simplified answer for this is 3x squared minus 12x plus 9. At this point, we are done. That is the derivative of this polynomial. The language here is a little bit hard to parse, but it's not all that scary once we kind of figure it out. So we're dealing with trying to find the derivatives of each of these things at the point where x equals 1. And these are our basic derivative rules that we've just uncovered. So this would be f prime of x plus g prime of x. This would be f prime of x times g of x plus g prime of x times f of x. And then we're going to have f prime of x times g of x minus g prime of x times f of x over g squared. Finding the value of each derivative when we equal 1 is going to be f prime of 1 plus g prime of 1. And we're given those values. F prime of 1 is going to be negative 4. G prime of 1 is going to be 2. In our next part, for the product rule, we're doing f prime of 1, which we said was negative 4, times g of 1. G of 1 is negative 3, plus g prime of 1, which is 2, times f of 1, which is 7. Let's be consistent, Mr. Carlson. So we got positive 12 plus 14 is 26. All right, and then finally we got the same thing going on here. So we got f prime of 1. I'm just going to write this one out first. G of 1 minus g prime of 1 times f of 1. This should be g of x squared, just so it's not confusing. And then we're going to find g of 1. Whatever it is, we're going to square it. When we do that, so f prime of 1 times g of 1, oh, those are the same things we just had in the previous problem. That's wacky. So I'm going to say this is just going to be 12 minus 14 on top. That's awesome. And then g of 1 is going to be negative 3. 12 minus 14 is negative 2. Over negative 3 times negative 3, we get negative 2 over positive 9. Nice.